Okay, back with the second part of the first lesson in Unit 4, or what at least at this point I'm calling Unit 4, the monomial and polynomial unit. So we're going to talk about multiplying monomials, so these should be some exponent rules that perhaps you've seen before. And we're going to talk about product rule. So product, remember, is the answer to multiplication. So these two monomials are being multiplied, hence the dot in the middle. And when we are multiplying them, we keep the base. So the bases need to be the same to use this rule. The bases are the same, and we add the exponents. Now you might say, why would we add? It's multiply. Well, let's think about what exponents mean as we do number 17. So for number 17, x squared, we know, means x times x. And x to the third means x times x times x. And then there was a times sign in between the two. And if I were asked to rewrite what is our expanded notation there as an exponent, it would be x to the, there are 5 of them, so x to the 5th. Not x to the 6th, right? There's just 5 x's written out there. So we can see from that I could simply have done x to the 2 plus 3 to get the 5. So we don't need to write it out every time. I just wrote it out that time to kind of show you why the rule works. In number 18, we are reminded that if there is just a variable like just this a, it is understood that it has an exponent of 1. So that then, this is what I'm thinking, right? I'm thinking, this is thinking, probably wouldn't usually write it, and then my answer would be a to the 10th. So then I have w, and then 7 plus 4, w to the 11th. So if there are coefficients, so if there are numbers in the front, notice that those numbers in the front, the coefficients, they're large, and the exponents are small and raised. Those large numbers don't behave the same way as the small numbers. This is still multiplication, so those coefficients are still going to multiply. So you should not find yourself doing the same thing with the coefficients as the exponents. So 4 times 3, 12, keep your base, and then 2 plus 5 makes that 12x to the 7th. So my coefficients are getting multiplied. Coefficients are getting multiplied. Base is staying the same. Exponents are getting added. So 5 times 6 is 30. X to the 6th power. A big difference between multiplying and adding and subtracting monomials is when we're multiplying monomials, they do not have to be like terms. In fact, they rarely will be like terms. If there's more than one variable as a part of the monomial, then they're usually arranged alphabetically, and you add the exponents separately. So, for instance, number 23 here has both A's and B's. So this is kind of like having 3 little problems all together. So first I'm going to think about -4 times 3. And what's here in the middle is kind of what's going on in my head. Would be -12. Then I'm going to move on over to my A's. so a, and then I'm going to add 3 plus 2 makes a to the 5th. Then I'm going to move on over to my b's, and remember this guy counts as b to the 1st, and this would be b to the 1 plus 5, which would be b to the 6th. If it helps you to write down what I wrote there in the middle, you certainly can, but usually that would just be happening upstairs. There could be more than 2 variables, like in 24 we have p, q, and r. So start out with those coefficients, -7 times -4. So when I multiply two negatives, I get positive 28. Then my p, 9 and 2 make 11. Then my q, 3 and 6 make 9. Then my r, 1 and 4 make 5. So don't lose track of if there is a variable without an exponent, it counts as 1. So you don't want to leave those off. Down in the bottom row that's currently on your screen, I'll talk about a few of those because they have fractions. Remember that a fraction, you're multiplying by the top and you're dividing by the bottom. So this becomes -3. Then my a's, 2 and 1 make 3, and my b's, 1 plus 1 makes 2. So 12 times 2/3, 12 times 2, 24, divided by 3 is 8. And then even though this first one doesn't have an x, we can still multiply these. I'm going to put the x first because I'm going to write it alphabetically, and then y to the 5th. It is equivalent if you write 8y to the 5th x. You'll just typically see it in the order alphabetically. You could have 3 different things being multiplied together. You could put the first 2 together and then the last one, or you can kind of do it all at once. So if I do 1/4 of 8 is 2. 2 times -6, -12. And then this time only 2 of them have variables, so 1 plus 2 makes 3. If you find yourself forgetting about that 1, give those guys their 1s that we are supposed to understand, and 1 plus 2 is 3. So if we look up at 28, there are actually 3 monomials being multiplied that all have x's and y's. So multiply those coefficients, and then when I add up for the x's, I've got 1, 1, and 2, which makes 4th power altogether. And then for y, I have 1, 1, and 3. 1 plus 1 plus 3 makes 5th power. All right, let's go now to the bottom of that page. And on the bottom of that page, where it says mixed practice, it's kind of more like combination practice. We're going to use the product rule, and then after we use the product rule, then we'll combine like terms and add and subtract things together. But remember, multiplication in order of operations, which still applies, multiplication comes before addition. And as they sit now, I couldn't add them anyway. So we're going to be doing this problem and this problem, and then if they are like terms, then we can add them together. So I have 2 times 4 is 8, x to the 5 plus 1 is 6, y to the 2 plus 3 is 5, and then I'm going to move over to the other side. So it's just a 3. Remember, this guy would be like a 1. 1 times 3 is 3. x to the 4 plus 2 is 6, y to the 4 plus 1 is 5, and then I see that my variables and exponents are the same, so I can add these together, but on the addition step, do not change your exponents, because I'm not multiplying them now. I've got 8 of these things plus 3 more of the same thing. I have 11 x to the 6th, y to the 5th. So I'll do one more of these, and then I'll pause, and I'll just give you the answer so you can check yourself on 37 and 38. So 5 times 4, a to the 4th, b to the 4 plus 2 is 6, and then over here I have negative 2, a to the 4, 2 plus 2, b to the 5 plus 1. Notice he doesn't suck off that a's exponent, he has his own 1, and makes 6, which is good because now they're like terms. And 20 and negative 2 give me 18, a to the 4th, b to the 6th. Okay, so I'm going to pause the video and then try 37 and 38 and then come back to check. All right, take a look. Hopefully for 37 and 38 you got the same thing. If by chance you wrote 1c to the 5th, d to the 2nd, that is the same thing. So that would be perfectly fine. And that should help you, the problems on this page should help you with the assignment for Unit 4, Homework 1, the bottom part of the page. All right, thanks, and I hope to see you in class soon.